Hello everyone. So hope you are doing very well. As you all know that today we are going to cover some exemplar questions from our NCERT textbook, and let's start our today's topic, that is NCERT chapter 3 chemical kinetics exemplar question 5, 6, 11, 17, 28 and 32. So these are the number of the questions exactly as per the NCERT textbook for which we are going to solve them in today's lecture. So let's start. So this is our disclaimer. Let's begin with our first question. The question is, consider a first order gas phase decomposition reaction given below. So we have given a reaction or mentioned a reaction here where A is the reactant and we are getting the product which is B and C in the gaseous forms. So this is a first order gas phase decomposition reaction. So in this single line there are many informations given. First of all, it is a first order. Okay. Secondly, it is gas phase reaction. That means all the reactants and the products are in the gas phases. And thirdly, it is a decomposition reaction. That means one thing is decomposing into two or many. Okay. So considering this reaction, initial pressure of the system before the decomposition of A was Pi. We have given that, let's suppose this is a system where this reaction is happening. Okay. Now the initial pressure of the system before the A is undergoing the decomposition process was Pi. The initial pressure was Pi. Now after the lapse of time T, total pressure of that system increased by X amount of units and became Pt. Okay, so system before the decomposition of A has the initial pressure of Pi, and after the time lapse of T, the total pressure will become Pt, which is increased by X units. The rate constant that is represented by K for the reaction this mentioned is given as. So you have to identify the rate constant, that is K, for this given reaction. Right? So try to remember the concepts which we have covered respected to the first order reactions in this chapter in the theory part, and try to solve this question. So options given for this question are K is equals to 2.303 divided by T log Pi upon Pi minus X. K is equals to 2.303 divided by T log Pi upon 2Pi minus Pt. K is equals to 2.303 by T log Pi upon 2Pi plus Pt, or K is equals to 2.303 divided by T log Pi upon Pi plus X. So every symbol we are using in our options have some meaning already mentioned in our question, right? Like Pi and Pt, K and T and X. Okay. So you have given some amount of time. Try to solve this using the concept we have studied in the chapter chemical kinetics. So after that, we will see that which option will correspond to the correct answer. Okay, let's see. So for this given question, the correct answer is first of all the second one. The second relation, which is given as K is equals to 2.303 divided by T log Pi upon 2Pi minus Pt. So this is the final rate constant of the given reaction. Now let's simplify that how we will get it. So to find the rate constant represents by K for first order gas phase decomposition reaction, this which is given by A in the gaseous forms converting to B in the gaseous forms plus C in the gaseous forms. So B and C are products. A is a reactant and this is a first order gas phase decomposition reaction. So we consider the reaction as that A is considering as reactant converting to B and C. Now at time t is equals to 0, because it is mentioned in the question that we are talking about the rate constant or the pressure of the reaction after the lapse of time t, right? So we consider that what is the pressure of our reaction which is happening initial and after the time lapse of t. Okay, so at initial time, that is at t is equals to 0, where the pressure of the A, that is reactant, is Pi, already mentioned, because it is not undergoing the decomposition. So before the decomposition of A, the pressure of the A is Pi. That means the pressure of B and C is 0, because decomposition is not happening at the initial time. So the pressure at T equals to 0 for B and C are 0 atmosphere each. Now, after the time lapse of T, so at time is equals to T, the pressure of the A reactant become Pi minus X. So some amount of the pressure will decrease for the reactant, because reactant is converting to the product, right? So some amount of itself is evolving into the products. So whatever the amount of the pressure is reducing from the reactant, that is going to be the pressure of the product. So if X amount of pressure is decreasing from the Pi of the A, that is the reactant pressure, that is the same amount, that is X atmosphere, which is forming or which is having the products. So B is having X atmosphere pressure, C is having X atmosphere pressure, and the A is decreasing its pressure by X units. Okay. Also, already mentioned in the question that after the lapse of time T, the total pressure of the system increased by the X units. That means the product having X amount of pressures for each. That's why the system is increasing by the X units of pressure. Okay, so this is the description that what is happening for our given first order gas phase decomposition reaction at the initial time and at the time T. So first of all, now what we will do, identify initial and final conditions. So initial pressure of the system before the decomposition of A is Pi, already given. Now after a time T, the total pressure of the system increases by X units, right? B become X pressure, for C also X pressure, right? So after a time lapse of T, total pressure of system increased by X units, which resulting into a total pressure which is denoted by PT. Now, secondly, we will relate the initial and the final pressures by the given condition. So the total pressure at time T, if you want to express it, how it can be? So it can be expressed as PT, that is total pressure at time T, is equals to the initial pressure plus the increase of the pressure in that lapse of time T, that is X amount of pressure, right? So PT, that is total pressure, is denoted by Pi plus X. Now rearranging gives the X value, that is the amount of the pressure which is increasing. If you want to calculate it in terms of the P total and the P initial, it will be P total minus P initial after rearranging this equation. Now thirdly, the R step should be determining the changes in the pressure, that how the pressure is going to change. So pressure of the reactant A is decreasing by X amount of pressure, X amount of unit, and pressure of products B and C is increasing by X amount of unit each. Therefore, pressure of A at time T is Pi minus x, because initially it has pi pressure. After the time t, it is decreased by x amount, so the pressure of the A, that is reactant, will become pi minus x. Total pressure at time t can also be expressed as the total pressure is equals to the pressure of A plus the pressure of the products, that is x plus x. Okay, so total pressure is considered as the whole pressure of the system, or you can say the sum of the pressure of the reactants and the products each. Okay, so the reactant is 1, that is A, so A pressure is at time t is pi minus x, plus the P pressure at time t is x, plus the C pressure at time t is x. So this is the total pressure. You can also write it as minus x and plus x will cancel out, remaining will be pi plus x. Okay, so P total will become pi plus x. Now this confirms our earlier expression for the P total, right? We have written that according to the given condition as per the question, P total is given as pi plus x, and after solving, after calculative way of determining the P total is also the same, that is pi plus x. Now fourth step is use the first order kinetic equation, because it is already mentioned that the reaction is of first order, right? The reaction is of first order gas phase, so we use here the first order kinetic. So integrating rate law for the first order reaction. Okay, so this is very important. You have to learn these things. Okay, other than the simplifying or deriving at that moment when you are requiring it during the solution of a particular question, you have to learn it. Okay, you should learn it and use it directly in the solution while solving. Okay, so the integrated rate law for first order reaction is given by time, that is t, is equals to 2.303 divided by k log p initial upon p initial minus x. So this is the integrating rate law in terms of pressure for a first order reaction, where t has a meaning which is time, k has a meaning which is rate constant, pi is the initial pressure representation, and x is the amount of the pressure exchanging, decreasing or increasing representation. Now we know the x value, which is pt minus pi, that is p total minus p initial. So we substitute the x value into this equation. It will going to get us the pi minus x will become pi minus p total minus pi. Right, now this negative sign multiplied inside the bracket, it will become pi minus p total minus plus p initial. So plus p initial will become 2p initial, and negative of p total will remain. So 2p initial minus pt will be the calculation after putting the x value in this pi minus x term, and where x is equals to p total minus p initial. Now, rearranging for the rate constant k. Now we have to identify that for the rate constant k, how you can rearrange that equation. Okay, we got the x value, we put it into the denominator of the log, which is pi minus x. So variable will cancel out. You can also give the answer in form of x if in our options the option are present in x variable units. Okay, then you can answer in the x terms, but if no x term is present in the option, then you have to find out the value of the x, and then you can put it inside the main equation, which we just find out by the integrated rate law equation for first order reaction, right? So we just rearrange it because we have to identify the rate constant k. So substituting substituting back into the rate law, so we will get t is equals to 2.303 upon k log of pi upon, here the initially term was pi minus x. Now pi minus x will be equals to 2 pi minus pt, that is 2 times p initial pressure initial minus pressure total. So this will be the rate law expression, right, after substituting the x value. Now we have to identify the rate constant k. So we rearrange this equation also to solve for the k. K will become 2.303 divided by t log pi upon 2p initial minus p total. Now final expression for the rate constant k. So the rate constant k for the reaction is given by k is equals to 2.303 divided by t log of pi upon 2pi minus pt. Pi is pressure initial and pt is total pressure. Okay. Yes, our reactant and the products are given in the gaseous phase. Okay, that's why we are using this rate law expression in the form of pressures. Okay, remember, we use wherever we have the gaseous phase of the reactant or the product, we use, regarding the concentration, we use the pressures of the gases. Okay, so that's why we write the rate law in the form of pressure, and our final answer, the final expression for our rate constant is coming out as 2.303 divided by t log of p initial upon 2p initial minus p total. And this will be the correct answer. Okay, so let's move to our next question. Now this is a MCQ and this is covering the NCERT section 3.3.2 and section 3.4. The question is saying that according to the Arrhenius equation, rate constant, that is K, is equals to AE to the power minus EA by RT. Which of the following options represents the graph of ln K versus 1 by T? So the question is saying that Arrhenius equation, rate constant is equals to, that means Arrhenius equation give the rate constant expression as that K is equals to A e to the power minus EA by RT. After knowing this equation, you have to select the correct graph which is representing between the ln K versus 1 by T. Okay, so we have given 4 options here where 4 different graphs are given. In the first graph, it is ln K versus 1 by T. The graph is a decreasing straight line of negative slope. In the second graph, there is an increasing slope straight line having some intercept on the y-axis. In the third graph, we have a straight line, increasing straight line starting from x equals to 0. And in the fourth graph, we have a straight line graph, increasing straight line having an intercept on the x-axis. Okay, so these are the 4 choices. So okay, so you have given some time, try to solve this and conclude at the correct option. Then we will see that how that will be the correct answer. Okay, let's see. So for this given question, the correct answer is option first, that is yes, option A, that is this decreasing slope straight line having the intercept on the y-axis, that is ln K. So the Arrhenius equation given by K is equals to A e to the power minus EA by RT is a fundamental equation in the chemical kinetics that relates rate constant, which is represented by K present on the left hand side of this equation, So it represents the rate constant of a reaction to several important factors like A, EA, R, and T. Okay, so the relationship between the rate constant and the other important factors, this Arrhenius equations gives that. Let's break down the equation and its graphical interpretation step by step. So let's see that how from this equation you can get this graph between the ln k and 1 by t. First step involves taking the natural logarithm of Arrhenius equation, of course, because this is given in the E, that is the E term. Okay, so a e to the power minus ea by rt, we take the log at both the sides of the equation. Starting with Arrhenius equation, k is equals to a e to the power minus ea by rt. Taking natural logarithm, that is ln, on both the side of this equation, we will get ln k equals to ln of this whole term. So ln of a multiplied by e to the power minus ea by rt. Now using the logarithm property, ln of xy will be ln x plus ln y. Okay, this is a log property that if two things are in the product and present inside of the ln, okay, so it can be put like ln x plus ln y. Okay, so this is the logarithmic property we use in this equation. So ln k will become equals to ln of a plus ln of e to the power minus ea by rt. Okay, so okay, now once more we will use the another logarithmic property here, which is using logarithmic property, that is ln of e to the power x is equals to x. Okay, so here whatever is going in the power, okay, so first of all log and ln is different. Okay, so log and ln is different. So basically in the log, the base having 10. In the log, when you write log, the base is having 10. Whereas in the ln, the base is having e. Okay, what is e? So e is basically, it has a name, exponential factor. Okay, it is a e, that is exponential function. So it has a particular graph. E has a increasing graph of curve like thing passing from the y-axis at some y equals to 0 or y equals to 1 to 2, in between of 1 to 2. Okay, so e is representing the exponential factor which is already present here in the base of the ln. So as I said that ln and log has difference, which is log, in the log there is a base 10 and in the ln there is a base e. There is a log property that if the base and the value of the ln, that whatever it is present inside of this bracket and the base are same, then this value will become 1. Okay, so yeah, e has a fixed value. Basically it has a value of 0.4 something. Okay, we take log e as 0.4. okay, so basically here ln base e and e to the power x is present. So the log property is if ln something has power in something. Okay, so here the x is in the power, so x from the power will go in the multiplication, so it will become x ln e. Okay, so whatever is present in the power in the exponential form, it will go in the multiplication, so it will become x multiplied by ln e. Now ln has base e and e here also, so this will become 1, so remaining thing, it will only be x, right? That's why we are saying here that we are using the logarithmic property, that is ln of e to the power x will be equals to x. Now where we use this? We use this in this second term present in the right hand side, which is ln e to the power minus ea by rt. So this equation will become ln k is equals to ln a. This already present in the power form, so it will go here in the multiplication, and ln base e will become 1. So the equation will become ln k is equals to ln a minus ea by rt. This minus ea by rt will go in the multiplication. That's why we are writing here it as minus ea by rt. Okay, so this is the equation. Now the second step involves the rearrangement into the form of a straight line. So if you want to get a graph basically from a given equation, first of all you want to convert it into some type of form, either curve form or either a straight line form, to get a graph, right? And it is already given that graph will be between the ln k versus 1 by t. That means that the equation of the straight line, in the equation of the straight line, the y will be going to as ln k and the x's will be going to as 1 by t. So to relate this to a linear equation or a straight line equation, we can rearrange the terms as ln k is equals to minus of ea by r multiplied by 1 by t plus ln a. This is the same thing. This is the same equation. We just rearranged to match it or to compare it with the straight line equation y equals to mx plus c. Okay. So ln k is given as ln a minus ea by rt, right? We can write it as ln k is equals to minus ea by r multiplied by 1 by t plus ln a. Why we write it in this form? Because as I said, we want y as ln k, x as 1 by t, and then we want to compare it with the equation of a straight line, which is given as y equals to mx plus c, right? So y is equals to mx plus c, and now y is ln k. So we take the ln k at left hand side. It is already at left hand side. So ln k is equals to y equals to mx. M is some slope multiplied by x. Now x we have to take is 1 by t. So 1 by t we are taking x, which is multiplication with ea by r minus ea by r. So this will going to be a slope of the line. Plus c, y equals to mx plus c. So c is some constant, which is here also ln a constant, because a is representing a constant or Arrhenius factor. Okay. Step 3 is relating to the equation of a straight line. Now we relate it or compare it with the straight line equation. This equation now directly corresponds to the equation of a straight line given by y is equals to mx plus c. This is the equation of a straight line. Y is representing by ln k, m is representing by minus ea by r, x is representing by 1 by t, and c, which is a constant, is representing by ln a, which is also a constant. So we don't, put here the y and x randomly, but it is already given that you have to make a graph between ln k versus 1 by t. That means y is ln k and x is 1 by t. So we convert this equation into this straight line equation form, and according to the y and x variable, which is already mentioned, which we already know. Okay. So y is equals to ln k, the natural logarithm of rate constant. X variable is 1 by t, which is the reciprocal of absolute temperature. M, that is slope, is minus ea by rt, where ea is activation energy and r is the gas constant. So this is a slope of line, which is a negative. Remember, it is a negative slope. C is representing the ln a, which is y intercept. Okay, so at the y-axis, whatever the intercept is going to come, the constant term, that is ln a, that is represented by ln a. So step 4 will be interpreting the graph. Now we have everything. We got our equation and the equation of straight line. We have compared the values, the every variable with the straight line equation, and we have get our variables or the terms which we are going to use to make the graph. So when you plot the ln k on the y-axis against the 1 by t on the x-axis, you will obtain a straight line. Slope of this plot will be equals to minus of ea by rt, minus of ea by r, which is negative. So r is a positive constant And a negative slope indicates that as temperature will increase, the 1 by T decrease, because the 1 by T is representing the x-axis, right? Negative slope means the slope is inversely proportional with the this x-axis, okay? And already in the x-axis, T is already present in the denominator, okay? So negative slope indicates that as the temperature increase, the 1 by T decrease, or 1 by T decrease, the rate constant will increase, okay? So we have a negative slope graph between the lnk and the 1 by T. Okay, so if you increase the temperature, that means this quantity which is present on the x-axis will decrease because T is present in the denominator. If you increase the temperature, this whole quantity of 1 by T will decrease. That means if you decrease the 1 by T, the rate constant is going to increase because it is represented by on the y-axis, that is lnk, right? So negative slope means the 1 by T is decreasing and the k is increasing. Okay. Now, a steeper negative slope implies a larger activation energy, that is EA. If you have a steeper negative slope, it is implying us, or it is saying that a larger activation energy is present. So a steep negative slope corresponds to high y-intercept, indicates a sudden fall in the collision frequency A with the decrease in the temperature. So we can also get another information from the graph that if you are getting a steep negative slope, that means we are having a larger y-intercept on the y-axis. Okay, if you remember our correct answers, correct graph, it will be going to start from a very high value of the y-axis, right? So we will going to have a high y-intercept, which is indicating that a sudden fall, that we are starting from a very high value, and a sudden fall in the collision frequency, that is A, is happening with the decrease in the temperature. Okay. As the collision frequency is decreasing, the rate is also decreasing, and hence the rate constant. So everything is in the decreasing mode. Like if collision frequency is decreasing, rate will also decrease and the rate constant will also decrease. Well, this is the concept wise thing, that if collision frequency, that means in per unit time, which amount of our molecules are colliding with each other for getting or converting into a product. Okay, so per unit time, the number of the reactant molecules which are colliding with each other, that is representing the collision frequency, which if is less, then the rate will also decrease, and hence rate constant will also. Okay, so this is the whole description, or you can say explanation, for identifying the correct graph of lnk versus 1 by T, or understanding the graph between the lnk and 1 by T, which we are getting from this Arrhenius equation, k is equals to a e to the power minus ea by rt. Okay, so let's move on to our next question. This is a MCQ, and this is representing or covering the NCERT section 3.1. The question is saying that which of the following statements is correct one. So we have given the 4 statements, as you can see in the options. You have to identify which statement is correct. Options are: rate of a reaction decreases with passage of time as the concentration of reactant decreases. Rate of a reaction is same at any time during the reaction. Rate of a reaction is independent of temperature change. Or rate of a reaction decreases with the increase in the concentration of the reactants. So we have given this 4 different statements. Identify the correct one. So try to remember the concept of the rate and how it is related with the concentration and temperature of a particular reaction, that how the temperature or the concentration is going to affect the rate of the reaction, which was the concept we have very in the starting covered. So try to solve this. You have some time, and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option first, that is rate of a reaction will decrease with the passage of time as the concentration of reactant decreases. So to understand the rate of reaction, we will follow two steps. The first step is defining the rate of reaction. First of all, we have to know that if we are talking about something, what is that? Okay, so here we are talking about the rate of a reaction. So first of all, let's define that what is particularly the rate of a reaction. So the rate of reaction is most commonly defined as rate of decrease of concentration of any one of the reactants with the passage of time. So in our reaction, whatever the reactant is present, its concentration plays the important role. Okay, so if we have given a rate of reaction, that means we are talking about the rate of decrease of concentration of any one of the reactant as the time passes. That means as the reaction will follow, right? Now alternatively, we can also say it like that it is the rate, as the rate of reaction increases in the concentration of any one of the products with the time. So rate will increase the concentration of any one of the products with the time as the reaction will going to perform, right? Because reactant will undergoing the process and converting to the product. That means the concentration of the reactant is decreasing and the concentration of the reactant is increasing. Secondly, expressing the rate of reaction mathematically. So mathematically, the rate of the reaction can be expressed using the differential notation, which describes the instantaneous changes. Okay, so mathematically, if you represent the rate of any reaction, you can use differential notation, and that means it will going to describe us the instantaneous changes happening in a reaction. So for the disappearance of the reactant, the general formula is rate of reaction is change in the concentration of reactant divided by the change in the time, right? So in how much time the concentration of the reactant is changing, that is also a definition of a rate of reaction. More precisely, if you talk for an instantaneous rate, the rate is defined as minus of change in the concentration of the reactant divided by change in the time, dt. So d is representing that something is changing, a small amount is changing. Okay, so in this particular change in time, whatever the amount of concentration of reactant is changing, that is representing the rate. And we are putting a negative sign because the concentration of reactant is decreasing. That is the negative sign is representing. So rate is minus dr by dt, where the r, the small r, is represents the rate of a reaction. The capital R in the square brackets denotes the concentration of the reactant. The dt is representing an infinitesimally small change in the time. And the negative sign is crucial. It indicates that concentration of reactant is decreasing with the time as the reaction progresses. Now, if we didn't include the negative sign, rate would be a negative value, which isn't intuitive for a rate. Okay, so if you don't put the negative sign here in the rate equation, the rate value would be a negative value. Okay, if you count, the rate is going to be negative. Okay, if you calculate, basically we are talking about calculation. If you have given a concentration at the final time and the initial time, and you calculate it without putting the negative sign, the rate value is going to be negative value, which isn't intuitive for a rate, which can't define rate. Rate is negative? No. So we are in the advance, we are putting negative sign because the concentration will going to be decreased. That means the value which we are going to get for the change in the concentration of the reactant will going to be negative. So that negative and this already putting negative will become positive and our rate will going to be positive. Okay. Now for the appearance of a product, similarly for the formation of the product, the rate would be R is equals to positive dP by dt, that is the change of the concentration of the product, whether it is increasing or decreasing, divided by dt. Here, this in the square brackets, P is present, representing the concentration of the product, and the positive sign indicates that concentration is increasing. And after calculation, the change of the product concentration, that is dP, is already going to be positive. Thus, for a general reaction, reactant converting to product, R or rate is given by minus of dr by dt, or it is also equals to positive of dp by dt. That is, you can define the rate in both the form, at either change in the concentration of the reactant or decreasing the concentration of the reactant with time, or increasing the concentration of the product with the time. Okay, so let's move on to our next question. Now this is a MCQ and this is covering the NCERT section 3.2. Question is saying that compounds A and B react according to the following chemical equation given by A plus 2B giving us 2C. Concentration of either A or B were changed, keeping the concentration of one of the reactants constant, and rates were measured as a function of initial concentration. Following the results were obtained, choose the correct option for the rate equation for this reaction. So what we are doing, we have given two compounds A and B which are reacting with each other according to this given chemical reaction. Now what we are doing, we are changing the concentration of either A or B, keeping one of the compound concentration as constant and another is changing. Okay, we are doing this and we are comparing this now with the initial concentration present. Okay, as a function of initial concentration, rates will going to be measured after the changing of the concentration of either A or B. This is the tabular data which we are getting after this experiment, and then you have to choose the correct option which is correct, representing the correct rate equation for this given equation or reaction. The tabular data is showing 4 columns: the experiment number, initial concentration of the A, initial concentration of the B in the mole per liter, and initial concentration of C in the mole per liter per second. Okay, so in the first experiment we have taken the A concentration as 0.30, B concentration similarly as 0.30. So the initial concentration of C you will get is 0.10. Now in the second experiment, initial concentration you take similar 0.30, but you change the initial concentration of B and double them to become 0.60. The initial concentration of C you will get is 0.40. Now in the third experiment, the initial concentration of A you have taken as 0.60. That means you double the concentration of the A as per the initial concentration of A, and you take the initial concentration of B as constant as the initial concentration of B. Now the finally C concentration will become from this 0.20. Okay, so visualizing on the basis of this tabular data given on the three experiments, you have to select the correct rate equation from the options. Options are rate is equals to k a square b, rate equals to k a b square, rate is equals to k a b, or rate is equals to k a square b to the power 0. So you have given some time, try to solve this, then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option B, that is rate is equals to k a b square. So to determine the rate law for a chemical reaction, first understand the rate of a reaction. So rate of reaction describes that how quickly the concentration of reactant changes over the time. For a general reaction, rate law is often expressed as R rate is equals to K concentration of first reactant to the power X concentration of second reactant to the power Y. X and Y where may or may not be equals to the stoichiometric coefficients of the respective reactants. So where the R is reaction rate, the K is rate constant, the A and B are molar concentration of reactant A and B respectively. And X is the order of the reaction with respect to A. Similarly, Y is the order of reaction with respect to B. Overall order of this reaction is going to be the sum of X plus Y. Now step by step how you can calculate. So as we have the following experimental data, that this is the tabular form of the data we have covered, right? You know, firstly we take some initial concentration of A and B and getting the initial concentration of C. Then we are changing the concentration of A and B one by one, by doubling one of the concentration and placing the another concentration as constant and getting the initial concentration of C. So first of all, determine the order with respect to the reactant B. To find the value of Y, we compare two experiments where concentration of A remains constant but B changes, like doubling in the first experiment and the second experiment. So in this case, we will use the experiment 1 and second experiment, which is given in the table. So rate of the first experiment divided by rate of second experiment will be K A to the power X experiment 1, B to the power Y experiment 1, divided by K A to the power X experiment 2, B to the power Y experiment 2. So basically we are comparing the rate of experiment 1 and 2. Now substitute the values from the table. We know the A and the B values for experiment 1 and 2. So when you substitute them, this will be going to the rate of experiment 1 and 2, that is K 0.30 to the power X 0.30 to the power Y divided by K 0.30 to the power X 0.60 to the power Y. Now when you simplify both the terms, we will get 1 by 4 is equals to 1 by 2 to the power Y. Basically we will cancel out whatever the term is going to be common, and the remaining term, the remaining values that can be cancelled out, that is solvable, and the final equation will become 1 by 4 is equals to 1 by 2 to the power Y Now we take the reciprocal on the both sides to get the simpler or the equation in the numerical form, which is 4 is equals to 2 to the power y. Other than the fractional form, we get this equation as 4 equals to 2 to the power y. Now 2 has something in the power which is equals to 4. So what you can put y equals to become this equation equals to 4? You can put the y as 2. Right? Express 4 as a power of 2. 4 you can express in the power of 2. 2 to the power 2 is equals to 4. So 2 to the power 2 equals to 2 to the power y. From here, y is coming out as 2. Now, with respect to the reactant A, the order you can find out by finding out the value of x by comparing the two experiments where we are changing the A concentration and P concentration we are taking as constant. That means we are talking about experiment 1 and experiment 3 as per the given table. So similar step we will going to do, we will going to compare the rate of expression third and the rate of expression first. Now we have to substitute the values from the table. This is going to be the equation, and when you cancel out the common terms, that is k and 0.30 to the power y, after solving this equation, you will get 0.20 by 0.10 is equals to 0.60 to the power x upon 0.30 to the power x. Here you can see only the numerical thing and something to the power x will remain. From here you can simply calculate that what will be going to the value of x, right? So you have to simplify both the sides to get the value of x, where 2 is equals to 0.60 divided by 0.30 to the whole power x. From here we will get 2 is equals to 2 to the power x. Now what you put x value to get this equation equals to 2? You put x equals to 1, right? So from here x will coming out as 1, and previously we find out that y is equals to 2, right? So from there you can get the rate expression for the given tabular experimental data, which is given by rate is equals to k times a to the power x, which is 1, multiply by b to the power y, which is 2. So a to the power 1, b to the power 2. That is going to be our answer for this question. Okay. Okay, so as we have our limited time, that's all for today's chemistry session. Thank you so much.